Today I'm going to show you how I made these little power bank cells. These are perfect for running an Arduino or an ESP8266. They're originally designed as a cell phone charger, but honestly you're not going to get a lot of charge out of a single 18650. But anyway, this is the final version. They come with these little circuit boards that have an integrated power as well as a boost converter. These are only running at about between 3.7 and 4.2 volts. So it's got a little boost converter so it can kick it up to 5 volts, and that'll work perfect for running our Arduinos. So let me show you where I got these cells and how I got them all put together. So a friend of mine over at Craig's Computer Services gave me a whole bunch of old laptop batteries from old laptops that were just being salvaged. And so they came in all different kinds of sizes and formats, but each of them will have anywhere between 3 cells and 5 cells in them. This one I've already cracked open. They're very difficult to get open, and you will have to use a screwdriver as well as some type of a sharp razor or some small screwdriver. The trick is where they have the connector is to start on that end and get them pried open. And the reason is because there's a little circuit board, and I'll show you here. This one's already been liberated from its case. So here they are on the inside. Now I always take them apart from the top up here because if I damage that circuit board, it's not a big deal. But you really wouldn't want to drive a screwdriver into one of these cells. Even though they're in a metal case, you kind of want to be careful. If you puncture one, it'll make a giant mess and it can easily catch fire. So once we take this out, and you'll see a lot of them will have either this glue, and this is kind of a hard stuck glue now. Some of it will be a little bit more sticky. But the next thing we need to do is we need to take this circuit board off, and we need to take all of these apart. And the way they're put together is through these spot welds. Now when you pry the little metal tabs off, what's left is going to be razor sharp, so you want to be very, very careful. So let's go ahead and take a couple of these apart. So usually what I do is I cut a couple of these tabs off, and they're usually a few that are easy to get to. This one has a little spacer in between them, so that'll make it a little bit easier, but you can pry them apart. Now you do want to make sure you don't short them out, so just be careful when we cut these apart. We just don't want to have the positive and the negative touch, and then generally they won't. But right here where I just cut that, so this is now going to be razor sharp, so you just want to be very careful. Now what I'm going to do is I'm going to take these pliers here, these cuts, and I'm just going to roll this back and pull that off. Now by doing so, I'm going to separate the batteries, but what's left on these tabs, as you can see here, it's going to be extremely sharp. So I'm going to take a screwdriver, and I'm just going to knock them down so that they're not as sharp. Now you can take a Dremel or something and pull those off entirely if you want. I usually don't bother because they're going to go inside those containers anyway, inside those cases, and therefore they're not going to be exposed anywhere. But you just want to be careful when you're doing that. So another thing that each of these battery packs has, you'll see, is this little sensor right here, and this is a temperature sensor, and it'll usually be taped. I just pulled the tape off from down in the middle here so that it can get a reading to see if these cells get too hot. So this is another little sensor that you could keep out of it. Now the boards themselves are pretty proprietary. I don't think you're going to find any components on here that you're going to want to salvage, but it's also not a lot of components on them. There's a couple proprietary surface mount ICs and a couple little resistors, so nothing of great value. So now that I've got these 2 cells out, I'll take the rest out in a minute. I do want to check the voltage on them, so let's see what we have. All right, so this one is 2.0 volts, and this one is also 2.0, almost 2.1. So that's extremely low for these cells. Now in my case, it doesn't really matter because I'm going to put these into single or dual cell battery packs like this one in order to power an Arduino. And so power isn't that important, but if we were going to do something like rebuild another battery pack for another device where we're going to have 2 or 4 or 6 cells, it's a good idea to keep the cells all from the same lot, like this battery pack here, as well as make sure they never drop below the critical voltage of about 3.0. So I'm going to go ahead and charge these up. I have a special charger right here that charges these 18650s, and they take about 3 hours to charge. These ones, being a little bit more dead, are going to take a little bit longer. Oops. to charge up. Now, you don't have to charge them first. We can put them right straight into those power banks, but I like to charge them on this charger. It just goes a little bit faster. So we'll come back when these ones are all charged up. I have all of the cells charged. I ended up with around 50 cells when it was all done. So now I'm going to put them in these little power banks. I got these from eBay. They sell for about $1 a piece, and they take a single cell. Now inside them, the back just screws off. This is actually machined aluminum. They're really nice little cases. So inside there's a little circuit board that it does, and it does two things. One, it's the charge controller to be able to charge the battery up when we plug it into USB here on the top. But then it also has a boost converter so that we can power at a consistent 5 volts. In normal use, this would be for charging a cell phone, but in our case, we're going to use it to power an Arduino. So the way this works is we just take one of these cells, and the cells are just like a AA battery. There's a kind of a button top and a flat top. So the flat top is the negative, so that pops in just like that. You do want to make sure you don't get them backwards, because I doubt these have reverse polarity protection, and they'll definitely fry that out if you get them in backwards. But anyway, just put the cell in, and then we're going to slide it inside this aluminum case, and they may be a little bit tight to get in depending on if there's any glue on any of those 18650s. We'll just screw the back on, and now we've got a little power bank. So the way these work is on the top with the micro, we can go ahead and plug that in for charging. So if the battery gets low, we can just plug this in. I don't know if you're going to be able to see, but there's a little light, little blue LED, and it's flashing blue and red, indicating that it's charging. Once it's completely charged, it'll convert to just straight blue. And we can go ahead and unplug that. And what we're going to use these for is in our Hack Sioux Falls event, we're going to use them to power the Arduino, so they don't need to be plugged into a computer all the time once they've been programmed. So these little charge ports work great because they stay consistent power on as long as something's plugged into them. So you can see this Arduino is now booted up. So anyway, that's what I'm going to do. I'm going to build about 35 or so of these, and I have them in a couple of different form factors. There's that nice aluminum, and then there's this little plastic one here that's exactly the same, but once you snap them together, you can't get them apart. They're kind of a one-way clip on them. But these work exactly the same, and I've got a couple of these as well, and I'm going to have a few different colored aluminum ones. So that's how I built those, and if you're interested in Hack Sioux Falls, I have a few tickets left. More than welcome to check us out at hacksioux falls.com.